Hi, this is Ahed with Logos Learning, and in this video, we're going to discuss stereoisomers. Now, what are stereoisomers? Basically, stereoisomers are compounds that have the same molecular formula, the same connectivity, but different spatial arrangement. So they are arranged differently in space. Now, stereoisomers, they cannot be superimposed. What does superimpose mean? Basically, superimpose means that you can put one on top of the other. So let's try this carbon dioxide here. See if these two molecules of carbon dioxide are superimposable. So we're going to select this carbon dioxide and I'm going to try to move it on top of the other one. There you go. Are they superimposable? Yes, they are. We can put one on top of the other and they look identical. Okay? Let's take a look at hands. Take out your right and left hand in front of you. If you can take a look at them, you see that the right hand is the image mirror or the mirror image of the left hand. Now, try to put the hands one on top of the other. Can you put them in a way where they are identical? Can you, even if you flip the right hand to be on your left hand, okay, they're not arranged the same. One is flipped up and one's flipped down. So hands, no matter how you put them, how you arrange them, they are not superimposable in the same way that the two carbon dioxide molecules were superimposable one on top of the other. Okay? So these two hands that we have are called chiral, and the word chiral comes from the Greek word for hands. Okay? Let's take a look at an example of an organic molecule or two organic molecules that are identical in every way except for in their spatial arrangement. So here we have one bromo, one chloroethane. Basically this molecule, if you take a look at it, here is a carbon. Okay, it's not working here already. Here's a carbon, and here's another carbon. So it is a 2-carbon long chain, and on the first carbon we have a chlorine and a bromine. So this is a 1 bromo because, bromo, B is first in the alphabet, 1 chloroethane. Okay? So if you see a dotted line, this means that this group is going into the page, and this solid line, the wedge here, means that this group is coming out of the page. So if you look at this, take a look at this. This is the hydrogen coming out at you. The bromine is going into the page, and these two groups, the chlorine and the methane group, are in the plane of the page. Okay? So this is 1 bromo and chloroethane, and here also we have a 2-carbon long chain. So 1 carbon here and another carbon. So again, on the first carbon we have a chlorine and a bromine. So this is also 1 bromo, 1 chloroethane. The only difference between these two is the location of the groups or the substituents. So here we have hydrogen coming out, bromine going in, and here we have a bromine coming out and hydrogen going in. Now, I cannot show you with a molecular model in this video, but hopefully in the next one. You cannot put these molecules in any way to make them superimposable on each other the way carbon dioxide molecules were. Okay, so here we have another situation like the hand situation. No matter how you turn them, they cannot be superimposed. And because of this reason, these are two stereoisomers. Okay? Now in organic chemistry, we refer to a chiral carbon or chiral carbons. What are chiral carbons? Well, chiral carbons are carbons that are bound to 4 different groups or substituents. Because you have a chiral carbon, your molecule will be a stereoisomer or a chiral molecule. Now let's take a look at an example here. Well, I said this is an example of 2 chiral molecules, and here I put another example. Here we have our first carbon. The first carbon here is bound to this other carbon and 3 H's. Is it chiral? No, it is not, because it's bound to 3 H's, which means it doesn't have 4 different substituents. Same thing with this carbon. This carbon is bound to this carbon and to this carbon and 2 hydrogens. So not 4 different substituents. Now this carbon right here is bound to an ethyl group, 1, 2, a methyl group, so we have a methyl here, we have an ethyl here, and we have 1, 2, oh, I got one more. We have another ethyl, we have a propyl, 1, 2, 3 carbons. And it's bound to a hydrogen. Now, because it's bound to 1, 2, 3, 4 different groups, this carbon right here is a chiral carbon. Chiral carbon. In organic chemistry, it's very important that you're able to identify which carbons in a molecule are chiral. Now, whenever you have a chiral carbon in a molecule, we have to assign the molecule an absolute configuration. When it comes to stereoisomerism, what is its configuration here? Okay, it can either be R or S. Now, if a molecule has a chiral carbon, to reiterate, we must assign an absolute configuration to the molecule based on this chiral carbon. And this is done in 3 steps. Now, the first step is to rank the substituents in order of increasing atomic number. So, high atomic number means high priority. Then you rotate the molecule so that its lowest priority group is in the back. So you can do this using a molecular model kit, or you can visualize it in your head. And with visualization, the more practice, the better it gets. I know it's hard at the beginning. So then you start counting. You go from rank number 1 to rank number 2 to rank number 3. And as you're doing this, if you're counting 1, 2, 3 in the clockwise direction, your molecule is an R. And if you end up counting in the counterclockwise direction, your molecule is an S. So let's try this. We're going to compare the carbon, the chlorine, the bromine, and the hydrogen. So here I'm choosing the carbon because the carbon here is what this carbon is bound to, this chiral carbon. That's what it's bound to. It's bound to this carbon, and this carbon is bound to 3 hydrogens. So we're comparing always the first group that is bound to that chiral carbon. So which one is a higher priority? Well, let's find the lowest priority. Which one is lowest? The hydrogen usually is the lowest. The molecular number, the atomic number for hydrogen is 1. Carbon and chlorine and bromine, let's compare these 3. Periodic table. So carbon has a number of 6, chlorine 17, bromine is 35. Which one is the highest priority? Well, bromine, then chlorine, then carbon. So let's number them. This is 4, well, ugly 4, but let's redo it here. So this is number 4, 4th priority. Carbon, well, this one is number 1. This one is 2. This one is 3. And so let's start counting. Hydrogen is already in the back, so we can leave it where it is, and we can start counting, and let's go see. 1, 2, 3. We're going 1, 2, 3. Am I going clockwise or counterclockwise? Well, I'm going clockwise. Let's write that down, clockwise. And if we are going clockwise, that means that the configuration here is R. So this is an R molecule. So I had mentioned earlier that these 2 molecules, because of how the hydrogen and bromine were arranged, these 2 are chiral molecules, and they are stereoisomers. So let's find out if this is a different molecule or the same one. Let's see if it's an R. If it's R, then these 2 molecules are superimposable and identical. If it's S, that means that these 2 molecules are stereoisomers and they're different molecules. Alright, so bromine is number 4. Bromine is number 4. Chlorine, oh, what did I say? Bromine is number 1. Thank you for catching that error. If you did, I hope you did. Chlorine is number 2. Carbon is number 3. And hydrogen is number 4. Okay? So if we take a look at this molecule, hydrogen is in the front. So all we have to do, we gotta rotate the molecule in such a way that the hydrogen is in the back. So imagine yourself grabbing this hydrogen and turning it all the way to the back. If you did that, it would look something like this. if I were to draw what would happen. Basically, my bromine will be on this side. If you turn it, the hydrogen will be in the back. CH3 stays where it is, and my chlorine goes here. Okay, so I'm just I'm visualizing it. That's how I turn it like this. So again, this is 1, this is 2, this is 3, and this is 4. Now let's rotate or turn, count. 1, 2, 3. So we're going counter clockwise. Okay, if we're going counterclockwise, it is an S. So these two molecules, this one and this one, are not identical, they are stereoisomers. Okay, they are stereoisomers. This is an R, 1 bromo, 1 chloroethane. This is an S, 1 bromo, 1 chloroethane. So I hope that this video helped, and in the next video I will be talking about what enantiomers are and what diastereomers are. Okay, so have a nice day, and I will talk to you later. Bye!